All right, hello everyone. Welcome to the second part of the Interim 2 review. So we're into section 9 now. Determine the domain and range of the graphs. Determine if each graph is a function, and then state the domain and range. So let's start with number 1. Number 1, the question is it a function? Yes, it is. If we draw a vertical line anywhere through the graph, it never intersects more than once. So that is a function. The domain are all possible x values. So our domain starts here at -4 and ends at 1. And there's a couple different ways we can write this. If we're using interval notation, it would be -4 to 1. If we're doing set builder notations, it's all values of x such that x is less than or greater than or equal to 4, but less than 1. The range would be from -4 to 6, or the range is all values of y such that y is greater than or equal to -4, but less than or equal to 6. And these less than or equal to's is why we have the square brackets. For number 2, yes, this is a function. The domain is all real numbers. If you wanted to write that in interval notation, that's -infinity to infinity. In set builder notation, it's a little bit more complicated, and if you didn't get taught this in class, don't freak out. But it's x such that x is a member of the set of real numbers. The range is 1 to infinity. Square bracket on 1, soft parentheses on infinity, or if you would prefer in the set builder notation, y such that y is greater than or equal to 1. Number 3, once again, yes, function. The domain is all real numbers, and the range is all real numbers. Because the domain and the range are everything. Okay. So for flashback review, number 1, the cube root of a number is less than the same number squared. Oh, the cube root of a number less than the same number squared. So that would be x squared minus the cube root of x. 5 times the square root of a number divided by 2. So 5 times, it's not 5 times the number, it's 5 times the square root of the number divided by 2. And the quotient of a number cubed and 7. So that would just be x cubed divided by 7, or x cubed over 7. All right, so into properties practice. Number 4. Which property justifies the work from given to step 1? So from here to here, what did they do? And that's the substitution property. 9 plus 2 is 21. If we know that 19 plus 2 equals 21, then anywhere we see that, we can write that. Number 5, what justifies the work from step 2 to step 2 to step 3? So step 2 to step 3 is what changed from here to here, and we distributed. And the last one is what justifies, for number 6, what justifies from 1 to 2. And what happened is we flipped that around, from step 1 to step 2, right there. And there we flipped it around, so that is the symmetric property. And the symmetric property says that if A equals B, then B equals A. All right, so now we're solving. Solve each equation below. So here, first I'm going to distribute, and I'll get 4 minus 2x minus 6. Remember, distribute the full negative 2 equals 12x minus 2x. On this side, we're going to combine like terms before we do anything else. And I'll get negative 2x minus 2 equals 12 minus 2x. Oh, we're going to have a problem. And then we're going to add 2x to both sides, and I'll get negative 2. I'm sorry, got ahead of myself there. Negative 2 equals 12. That's not a true statement, so this is no solution. Remember, whenever either your variables disappear, if you end up with an untrue statement, then it's no solution. If you wind up with a true statement like 5 equals 5, then it's infinite solutions. All right, let's try this one, which I think is what we're about to see. So on this side, I'm going to combine like terms. And on this side, I'm going to combine like terms. And if I subtract 4x from both sides, to try and get the x on the same side, I end up with 8 equals 8. So this is all, well, let's call it infinite solutions. All right, so number 9, let's see if we get one that we actually have to solve. So I distribute here, and I'll get 1 minus 3x minus 6 equals, combine like terms, and I'll get x minus 5. Combine like terms over here, and I'll get negative 3x minus 5 equals, let me just double check that I'm doing this right, equals x minus 5. I will subtract x from both sides, and I'll get negative 4x minus 5 equals negative 5. I add 5 to both sides, and I'll get negative 4x equals 0. Now this is not no solution. If I divide both sides by negative 4, I get x equals 0. Remember, 0 divided by a number is 0. We cannot divide by 0, but we can split 0 up into pieces. Each piece is 0. Now remember, we should double check our answer. So if we plug 0 in for x, on this side I'll get 1 minus 6 is negative 5, and on this side I'll get 2 minus 7 is negative 5. So that is in fact the solution. All right, using the ordered pairs shown, create a relation containing the 3 ordered pairs with a domain of negative 1, 0, and 3. Remember, domain means x. Range is the y values. So what are 3 points with and those would be my 3 points that I would drag down into these boxes if it was on the test. This would be Next up, we have to solve the inequality. Remember, you solve an inequality just like you solve an equation with one extra step, which will not come into play here, which is that if we divide both sides by a negative, we flip the inequality. So I'm going to go because x is less than, we'll start at 8, but x is smaller than 8. So there's our solution. Right, for this one, here's where we're going to see the extra rule, which is the negative x is less than or equal to 7. So I'm going to have to divide both sides by negative 1. But when we divide both sides by negative 1, when you multiply or divide both sides by an inequality, you have to flip the inequality, and we'll get x is greater than or equal to -7. So I would have a closed circle at -7, and I would shade up because x is bigger than 7. Right, for this one, this is easy, just subtract 8 from both sides, and I'll get -2 is greater than or equal to x. Closed circle at -2. X is smaller than -2, so we're shading down. Almost through here. Solve the inequality for y. Subtract 2x from both sides. I'll get 6y. These are not like terms, so they can't be combined. And divide everything through by 6, and I'll get y is less than -2, 6x plus 12 over 6, or, simplifying all the fractions, y is less than or equal to -1/3 x plus 2. This one says solve for y, so I will. So I subtract 6x from both sides, and I'll get 3y is greater than -6x plus 15. Divide everything through by 3. All right, Ali heard that it's 55 degrees Fahrenheit outside. If F equals 9/5 C plus 32, where F represents the temperature in degrees Fahrenheit, what is the temperature in degrees Celsius? Sorry, this should be comma. This should be lowercase w, but whatever. Round to the nearest tenth. So they give us 55 Fahrenheit, so we'll plug that in for F. So I'll get 55 equals 9/5 C plus 32. So I'm going to have to subtract 32 from both sides, and I will get 23 equals 9/5 C. And if I want to clear that fraction, I just multiply by the reciprocal. Those cancel. And I'll get, sorry, my calculator just died. $12.7. It says round to the nearest tenth, so 12.8 equals C. So the temperature is 12.8 degrees Celsius. We have one problem left. All right, I believe this is the last problem here. So for this one, Sarah has a backyard in the shape of a triangle with the dimensions shown below. If the perimeter of the yard is 2,988 feet, what is the value of x? Well, to find the perimeter, we add up all three sides. So this will be 8x plus 30 plus 13x minus 2 plus 7x plus 6. And, whoop, sorry, wrong thing I was trying to move there. And, oh, man, smartboard's being a little problematic today. All right. Well, anyway, all of that has to add up to 2988. So 2988 equals, combine all the x terms, 28x, and combine all the constants, plus 34. Subtract 34 from both sides. And that's 2954 equals 28. Divides both sides by 28. And I'll get x equals 105.5. Let me just double check my math there. Okay, that's it. So everybody have good luck on the exam. If you have any questions, ask your teacher next time you're in class.